Hello everyone, welcome to Site Programming channel. I am Hemanth from the stream of Information Technology 3rd year at Sisi Institute of Technology and Engineering. I am submitting the video assignment on rightmost derivation in automata theory and compiler design under the supervision of Nageshwar Rao sir. So before going into the actual content, let us know what is meant by rightmost derivation. The process of deriving a string by expanding the rightmost non-terminal at each step is called rightmost derivation. Wherever the geometrical representation of rightmost derivation is called as a rightmost derivation tree. So let us see an example to get more clarity about this topic. So consider the following production rules of a grammar, and he has given a set of four production rules, and he asked us to derive the string which is naming W using the rightmost derivation. So these are the given production rules, and this is the string which you have to derive. So from the given string, we have to identify the first character of the string, because the process of solving a rightmost derivation tree is from left to right. So the first character is X. So from the given production rules, we have to identify which production rule can be written as which is starting with the X, and that should be followed by the non-terminal, because we can extend only the non-terminals only, where here X is a terminal. So there are actually three rules which are starting with X and they are following by the non-terminal. So before for solving this, you have to remind one thing: there are actually n possible ways to solve a rightmost derivation tree. So from those n possible ways, I am choosing one possible way here. So I am choosing the production rule where S can be written as XB. So here we have to represent the S as a root node, whereas the X and B are the child nodes. So here you can observe that the first character of the string is completed. Now we have to find for other character, that means followed by second character. So here the non-terminal is B. So we have to extend the non-terminal. So how we have to extend? So we have to identify among B production rule which is starting with X, and that should be followed by other non-terminal. So here in this production rule B, where B can be written as XBB. So here it is starting with X and they are followed by two non-terminals. That means we can write B can be XBB. So here two characters from the string are completed. Now we have to move to the another character. So here we have to derive another non-terminal. That means we have to extend another non-terminal. So the another character of the string is X. So we have to write B as starting with the terminal X, and they should be followed by another non-terminals. So here I am choosing again the same production rule where B can be written as XBB. That means here is the representation. So here the three characters of the string is completed. Now we have to move upon to the fourth character of the string, where the fourth character is Y. That means now here we can observe that we have to extend the non-terminal B. So we have to choose among the production rules which we can return B as with starting Y and followed by the non-terminal. But here I am choosing B can be written as Y production rule, because there is actually another two non-terminals B which we have to extend. So for the sufficiency, I am choosing the production rule B can be written as Y. Here you can observe that the four characters of the string are completed. Now we have to move for the fifth character. The fifth character of the string is Y. That means we have to extend the non-terminal B to the Y. So for that I am again choosing the same production rule, that is B can be written as Y. Here is the representation. So here the five characters of the string are completed. Now we have to move for the sixth character. Here the sixth character is X. So the non-terminal left here is B. So we have to write B which is starting with terminal X, and that should be followed by any non-terminal. So here I am choosing the production rule B can be written as XBB. So here this is the representation. Here totally 6 characters are completed. Now we have to move for the 7th character. Here the 7th character is Y. So for the Y, here I am extending the B non-terminal with a production rule. B can be written as Y. So here this is the representation. So and the 8th character is Y. So here the non-terminal left here is B. So we have to write B as starting with the terminal Y, and that should be followed by the any non-terminal. So for that I am choosing the production rule. B can be written as YS. So here this is the representation. Here totally 8 characters are completed. Now we have to move for the 9th character. Here the 9th character is Y. So here that non-terminal left here is S. So we have to extend the non-terminal which is starting with the terminal Y, and that should be followed by the non-terminal. For that I am choosing the production rule. S can be written as YA. So this is the representation. So here totally the 9 characters are completed in the string. The only character left here is, that is the last character, X. So here the only non-terminal left here is A. So for this we have to extend the A to the X. So for that I am using the production rule. A can be written as X. So this is the representation. Here we can observe that the total string is derived. So you can observe that all the characters are highlighted in red color. So by combining all those we can get the required string W. So for like this we can derive the rightmost derivation tree. So since we, as we discussed before, that means the rightmost derivation follow the process from left to right. So for that I have chosen the production rule, which is for any non-terminal which is left over there. So there should be starting of the terminal, and that should consist of the non-terminal. So these are the points which we have to keep in mind. So thanks for watching. Please like, share and subscribe.